Here we are with Venn diagrams. And Venn diagrams are fun. You've seen them before. You probably saw them a lot in lower school. But they're just a visual way of displaying relationships between sets. So it's a lot of what we've done, but now we're going to put it in a pictorial form, which makes sometimes it easier to see. So if you look at this, we've already done statements like this before. And so all of P is in Q. So what we can say here is that if P, then Q. So that statement holds true. All elements of P are also elements of Q. If I look over here, if all of this is shaded in, and it's P or Q, if something belongs to one of these, this is a or statement. It could be P or Q if it's in here. If only this part is shaded, that means a P and a Q are in there. So this, when they're intersecting like that, this is some or sometimes. Over here, they will never have a relationship. P will never be a part of Q, and Q will never be a part of P. So that's kind of what it looks like. And now we are going to go through some examples, and we are going to give them a Venn diagram. So if you look at number 1, some students who take chorus also take band. So here's chorus, and here's band. They also take band. So that would be the intersecting part right there. Number 2, no perfect squares are prime numbers. So these are perfect squares. These are prime numbers. Number 3, numbers divisible by 6 are always divisible by 3. So these are the ones that are divisible by 6. And this is divisible by 3. Numbers divisible by 6 are always divisible by 3. Number 4, every natural number is a whole number. This is a natural number, and this is a whole number. Every natural number is also a whole number. Number 5, some vertical angles are complementary. So I can have vertical angles over here and complementary angles over here. Irrational numbers are never rational numbers. So that's what those Venn diagrams. Now, let's take into account some of the shading that happens. So if I wanted to make this shading true where Q is represented, I'm going to shade in all of Q because that's what I need. This says P and Q. So if I'm P and Q represents this area in the middle. P or Q, for something to be P or Q, you're shading everything P or Q. Now look at this one. This says P and not Q. So this is P, but not Q. See how that works? So these are good visual diagrams. Now, let's make a statement. So if I wanted to describe this, I would say if an angle measures 60 degrees, then it is an acute angle. So remember, when you have these Venn diagrams, if P, then Q. So if an angle measures 60 degrees, then it is an acute angle. So these are conditional statements. 11 and 12 are conditional statements. So number 12, if it is a beagle, it is a dog. And I would say I wouldn't say it. If an animal is a beagle, then it is a dog. Now, look at number 13. So it's just that middle people. So remember, this is a some or sometimes statement. So some students play volleyball and take piano lessons. Some students play volleyball and take piano lessons. look at number 4. Months with 31 days, but are not months that start with J. So 14 would say the months with 31 days, but do not start with J, because this is P, not Q. P, not Q. All right, number 15. So this is students that are freshmen that do not take art classes. Students that are freshmen but don't take art. So students that are freshmen and do not take art. All right, number 16 is an or statements. So multiples of 7, some multiples of 7 or are an even number. So, excuse me, this is a sum statement. So I'm going to say some numbers, or I can say numbers that are numbers that are multiples of 7 or are even numbers. So that's my big or statement. All right, I'm going to stop this video here.